Okay, what we're going to talk about in this short video are the topics for week 4, for the lesson in week 4, which includes significant figures, determining how many figures are significant within a specific number that you're analyzing, as well as how to use the appropriate number of significant figures when you are rounding. So there are different rules between when you add numbers and subtract them and round with the significant figures, and the different rules between addition, subtraction, multiplication, and division when rounding. So we'll go through those things. And then finally we'll end with scientific and engineering notation and learn what the differences are between the two and how to turn a number into scientific and engineering notation. So the first thing we'll talk about are significant figures. Now, really what you have to do is just learn the rules. And then once you learn the rules, you'll apply those rules to a number that you're analyzing. So when you look at the number that you're trying to figure out how many significant figures there are, what you do is you look all the way to the left, and the leftmost digit, which is not a 0, so you go all the way to the left, find the leftmost digit that is not a 0, and that's called the most significant digit. Then you look at your number, and if the number does not have a decimal point in it, then you look all the way to the right, and you look at the rightmost digit, which is not a 0. So if you do not have a decimal point in your number, then the rightmost digit, which is not a 0, is considered the least significant digit. On the other hand, if your number does include a decimal point, then your rightmost digit is the least significant digit even if it's a 0. So you go all the way to the right, and even if it's a 0 at the end, that becomes your least significant digit. And then every digit in between, so you count the least and the most significant digits, as well as everything in between, and that's the number of significant figures that is in your number. So if we look at just this little short example here, the question is, how many significant figures do each of these have? So if I look at this first number here, 1, 2, 3, okay, the leftmost digit is the most significant, and that's a 1. Then I look all the way to the right. Now this number does not have a decimal point, so the rightmost digit, which is not a 0, is the 3. So this number, 123, has 3 significant figures. Now the next one down, we look at 123,000. Once again, you go all the way to the left. The leftmost digit is a 1. And this is the leftmost non-zero digit. That's the most significant figure. Then you look and you determine if there's any decimal points. Well, no, there's no decimal points in this figure. So now what you do is you look all the way to the right till you find the rightmost non-zero number, which in this case is the 3, because these zeros then don't count. So this number has 3 significant digits as well. Then this one down, 12.3, once again you look to the left, the leftmost non-zero number is the 1, that's the most significant digit. It has a decimal point, so we look all the way to the right and we find the rightmost digit, whether it's a 0 or a non-zero number, and in this case it's a non-zero number of 3. So this one has 3 significant digits too. Now if I go down here, the last two, 1.00, the leftmost digit is a 1. It has a decimal point, so I'm going to go all the way to the right, even if it's a 0, and that's also significant. So 1.00 has 3 significant digits. And this last example, 0.000123, we go all the way to the left with the non-zero, which is a 1. Then you go all the way to the right, whether it's a 0 or a non-zero, because it has a decimal point, and this is the 3. So this also has 3 significant digits in it. Okay, so that's just the major rule that you need to follow there. And here's another little picture that shows some of the rules. Okay, zeros that come before the leftmost non-zero number are not significant. The leftmost non-zero is significant. And since this has a decimal point in it, that the rightmost 0 is the least significant digit. So all of these in between count. So this one would have 1, 2, 3, 4, 5, 6, 7 significant figures in it. So when we are dealing with rounding with significant figures, there's different rules between addition, subtraction, and multiplication and division. So for addition and subtraction, what you do is you take all of your numbers that you're going to add or subtract, and you add and subtract as normal, keeping all of the digits in play. And you get an answer. Okay, so this example here, we're adding up all these 4 different numbers. We're going to keep all of the digits. We're going to get this number at the end, 261.2290. And if we want to round this to the appropriate number of significant digits, we look at all of these numbers that we added together, and we look at which one has the least accurate decimal place. So if I look at all of these numbers, the least accurate decimal place is this tenths place, which is the 234.6 number. That's the least accurate decimal place out of all of them. So what we're going to do is we're going to round this answer 261.2290 to the tenths place. So we'll get 261.2 because the tenths place is the least accurate. Now on the other hand, with multiplication and division, you're going to take all of your numbers and you'll multiply and divide as usual. So don't round anything in your initial numbers here. Keep all of the digits. So in this example, if we multiply these 3 numbers, we get 17.614975. But instead of looking at the least accurate decimal place, what we're going to do is we're going to round to the least number of significant digits from all of the numbers. So this number has 4 significant digits. This number has 3 significant digits. And this number has 1 significant digit. So what we have to do, this 5 has 1 significant digit. So we are going to round the 17.614975 to 1 significant digit, which means we have to round this all the way up to 20, because 20 only has 1 significant digit. So there's no decimal in this number. Right? There's no decimal in here. So 20 has 1 significant digit. Okay, so the second to last topic that we're going to talk about is scientific notation. And scientific notation is just a way that in engineering we can handle very large numbers or very small numbers and only include the significant digits. Okay? So, for example, instead of writing 0.00054, we can bring the decimal over. We'll bring the decimal over 1, 2, 3, 4 spots to the right, and we'll get 5.4 times 10 to the minus 4. So very small numbers, you'll see a negative exponent, because we're going to move the decimal point to the right. When we move the decimal point to the right, we're going to get a negative exponent. So the number of significant digits in 0.00054 is only 2, because the leftmost non-zero is 5 and the rightmost digit is 4. So there's only 2 significant digits in this number. So our scientific notation will also only be 2 significant digits, 5.4. Now the next example, 455,000 the leftmost non-zero number, which is the most significant digit, is the 4. This one does not have any decimal points, so our rightmost digit that is not a 0 is the second 5 here. So we have 3 significant digits within this number. So what we're going to do is, if we did have a decimal, it would be after the 0, that last 0 there. So we're going to move it over to the left, 1, 2, 3, 4, 5. So our scientific notation would be 4.55, because it has 3 significant digits, times 10 to the positive 5, because we moved the decimal. If there was a decimal, it would be after the 0, and we moved it over 5 places. So remember, large numbers have positive exponents, and small numbers have negative exponents. So here's some examples. This number, 0.00682 in scientific notation, we're going to move the decimal over 1, 2, 3, so it'll be times 10 to the minus 3, and we only have 3 significant digits, 6.82. 1.072, this is already in a very simplified manner, right? We already have our 4 significant digits, 1.072. So what we do in scientific notation is we would say times 10 to the 0. We're actually not even moving the decimal point anywhere. So it's just times 10 to the 0. 10 to the 0 is basically multiplied by 1, okay? 300, now 300 does not have any decimal point, so we only have 1 significant digit. So we can say it's 3 times 10 to the positive 2, because we're moving, if we had a decimal, it would be after the 0, and we're moving it in 2 places. Now, if there was a decimal point in the original number, now we have to include all 3 as significant digits, so it becomes 3.00 times 10 to the 2. And then 300.0, all 4 are significant, so we have to bring all 4 digits in, 3.000 times 10 to the 2. Okay. Now last we're going to talk about engineering notation. And engineering notation is just a version of scientific notation in which the exponent of 10 must be divisible by 3. So this gives you, the reason why we do this in engineering is so that you can say, okay, this is the thousands number, this is 10,000, so kilo, mega, giga, those kinds of prefixes you can use very easily in engineering. So those work because they are factors of 3. So each of these exponents must be divisible by 3 in order to make it engineering notation. But you still always want to include only the significant digits in your answer. So if we looked at this first number, 43712, that has 5 significant figures. To make it into engineering notation, our exponent of 10 must be divisible by 3. So we could bring the decimal point after the 2 over 1, 2, 3, and it would be 43.712 times 10 to the 3. Or we can bring it over to 6 places, which would bring it to 0.043712 times 10 to the 6. And notice all 5 of the digits are showing in the answer because they are all significant. Now this second example, we have 0.036. Only 2 of these are significant figures, the 3 and the 6. So we can bring the decimal point over 1, 2, 3, and we have 36 times 10 to the minus 3, because that's divisible by 3. Or we can bring in another 3 and have 36,000 times 10 to the minus 6. But notice, our answer still only has 2 significant digits in it.